So direct variation is represented by the formula y equals kx, where k cannot equal 0. So k represents our constant of variation, and x represents our variable or our input to our equation. So an example, a constant of variation can be the same thing as our slope. Okay? All direct variation lines must cross through the origin, which is 0, 0. So in upcoming lessons, we are going to look at different formulas for linear functions. Direct variation is really just the baseline in which we work from. Okay? Looking at examples. So it's wondering, is this direct variation? So in order for it to be direct variation, it must go through the origin, or 0, 0. In this case, it does. So yes, it's direct variation because it goes through 0, 0. Okay, now it's wondering what our k value is, which is our slope. So in order to find our k value, we have to find the rise over run for this line. Okay, if we're looking at our rise, we move up 3. We also move over 3. So our rise over run, we rise 3, we run 3, which 3 divided by 3 can be simplified as 1. Okay, if we were asked to write a formula for this, remember we have y equals kx. So our formula would be y equals k, which is 1 times x. That is a direct variation equation. Okay, example number 2 here. Is this direct variation? Well, in this case, you can tell that this line does not go through 0, 0, or our origin. So no, this cannot be direct variation because it doesn't go through 0, 0. Okay? So really, that's all there is to direct variation and looking at direct variation graphs. But the more important part to this lesson is that we have to solve for y in some of these cases of direct variation. So to solve for y, we just have a couple of steps here. So step number 1, we have to move x to the opposite side of y. Okay, we will move x to the opposite side of y by adding or subtracting. Okay, adding or subtracting it to the other side. Step number 2, we have to isolate our variable y by, either using addition or subtracting. So that's getting rid of our coefficient on y. Number 3 is just simplify. If we have any fractions or anything like that, we just need to make sure that we simplify when needed. Okay, so I know I didn't give you a space for this, but make sure you have this jotted down somewhere within your notes. Okay, So let's look at a couple of examples for solving for y. Okay, we're just going to do the left side here. We'll save the right side for class. Okay, so when solving for y, we need to first make sure that we move x to the opposite side of y. In this first example, we don't have x. So we can move to number 2. So our key here is to isolate y. So remember, we have to follow our reverse PEMDAS. So let's start by getting rid of our constant 7. So we can subtract 7 from both sides. That leaves us with 3y equals 4 minus 7, which is negative 3. Now, in order to completely isolate our variable, we must divide our coefficient of 3. So we'll divide both sides by 3. Gives us y equals negative 3 over 3, which is just negative 1. Okay? Pretty straightforward. We have solved many equations like that already. For example number 2, we do have an x in this case. So our first step is to move x to the opposite side. So in order to move a positive x to the other side, we must subtract x from both sides. Okay? That will leave us with y equals, you always write your variable first, so negative x plus 8. Okay, when you have multiple variables like this, there is no further solving that we can do. So we have to leave our equation just like this. Okay? In our third example here, we have 9x plus 2y equals 6. So we first need to start by moving moving x to the opposite side of y. So if we want to move positive 9x to the other side, we can just subtract 9x from both sides. Okay? This will leave us with just 2y on our left side equals negative 9x plus 6. Okay, we are completely solving for y, so we must get rid of our coefficient. So 2 times y, to undo multiplication, we must use division. Be careful here. When you divide 2 from this side, we must divide 2 to every element on our right side. So this leaves us with y equals negative 9x over 2, which we can write as negative 9 halves x plus 6 divided by 2, which is just 3. Okay, before we can just call it good, we must check step number 3. Can we simplify our fractions? In this case, we cannot, so that is just our final answer. Okay? And finally, for our last example here, solving for y. First, we need to move x to the opposite side of y. Y is on our left side, x is on our right side. Nothing we can do there. So now we just need to work on isolating y. So on the left side with y, we do have this plus 3 constant. So let's move it to the other side by subtracting 3 from both sides. Okay, that'll leave us with 2y, our 3's cancel, equals 3x. And remember, you can only combine like terms. So we cannot subtract 3 from 3x because they are not like terms. But you can subtract 3 from our constant 3 on the other side. Okay, 3 minus 3, that gives us 0. So essentially, both sets of our constants just cancel each other out. So that leaves us with 2y equals 3x. So in order to completely isolate y, we must divide our coefficient of 2. Okay, this will leave us with y equals 3 halves x. And once again, this is a fraction that cannot be simplified. So we can leave our equation just like that. Okay? I would highly recommend that you guys try the other 4 on your own before you come to class, but we will start class by going over them just to make sure that you completely understand this process because it is extremely important to the rest of our year. Okay, last example. We have a bit of a word problem. So suppose y varies directly with x. So we have direct variation. Okay, let's highlight our important info first time we go through it. So suppose y varies directly with x. So it tells us we have a direct variation problem. When x equals 10, or y equals 10, and x equals -2, what is the direct variation equation? What is the value of y when x is -15? All right, so the first thing that we need to find in this case is our direct variation equation. Then we can focus on the second part of our problem. So in order to find our variation, let's use our direct variation equation. So that's our y equals kx. So really, in order to form an equation that we can substitute our x value into, we must solve for k. Luckily, we already do have one set of y and x values. So let's substitute those values into our equation. So for y, let's substitute in 10. We are trying to find k. And for x, let's substitute in -2. Okay? So this leaves us with 10 equals k times -2. If we are trying to solve for k, let's undo our multiplication here by dividing both sides by -2. Essentially, that will cancel our -2 out on our right side. So 10 divided by -2 gives us -5, which equals k. All right, now that we've found our k value, or our constant of variation, we have a full direct variation equation here. Y equals -5x. So if we're trying to find the value for y when x equals -15, let's just substitute -15 in for x. So that gives us y equals -5 times -15. Okay, -5 times -15 gives us y equals 75. So that is our y value when x equals -15. All right, so hopefully that gets you guys started on solving direct variation equations. Please come to class with any questions you have. Thanks for watching.